Welcome to Naradar Academy. In this video, we are discuss about couples. Two equal and unlike parallel forces which are not acting at the same point are said to constitute a couple. Okay, see, look at this figure. Here I have two equal forces F acting at two different points A and B. First F is acting at A and the second one is acting at B. Okay, and they are parallel. The line of action of the forces are parallel to each other and they are unlike parallel forces. What do you mean by unlike? The directions are in opposite sides. Okay, so these types of forces together constitute a couple. Okay, so two equal unlike parallel forces which are not acting at the same point. If they act at the same point, the resultant will be zero. So that is not a couple. Okay, so they should be acting at different points. So winding a clock and turning a tap are example for couples. So here when you apply this force, this couple on a rigid body, okay, it will create a rotatory effect on the body. Only rotation will be there and there will be no translation. Translation means what? Moving from one position to another position. That type of movement will not be there. There will be only what? Rotatory effect. So that is what happening in turning a tap and winding a clock. No, so they won't move from their position, but there will be some rotation, isn't it? So this is the action produced by a couple on a rigid body. Okay, right. Next one is moment of a couple. Couple is measured by means of its moment. The moment is given by, see, two forces are acting. No, you take any one of the forces and you take the perpendicular distance between the line of action of the forces. See, this is the line of action of the first force and this is the line of action of the second force. No, you measure the perpendicular distance between the two lines of action. Okay, then the product of the force into their perpendicular distance will give you the moment. So each couple is characterized by its moment. So this is the measure we find every time whenever we talk about a couple. Okay, so the moment is equal to what? F into P. And this perpendicular distance is there. No, this is called arm of the couple. Okay, the perpendicular distance between the lines of action of the forces is called arm of the couple. And a couple is usually written like this within brackets. The force, the first component is force, comma, the second component is its arm of the couple. So this is how we represent a couple. Okay, then next one is equilibrium of two couples. So when will you say two couples are in equilibrium? See, when will you say two forces are in equilibrium? When the resultant is zero. In the same way, when you have two couples, they will be in equilibrium when they have equal and opposite moments. Okay, so what do you mean by equal and opposite moments? The moment are equal in their magnitude. I have two couples which have equal magnitude of moment, but the sign will be different. Okay, if one is plus Fp, the another moment, another couple's moment should be what? Minus Fp. If in that case, what do you say? The couple are in equilibrium. Okay, so two couples are said to be in equilibrium when they have equal and opposite moments. That is, the moments are equal and opposite. Next one is equivalence of two couples. So when will you say two couples are equivalent? The same concept only. So the two couples are said to be equivalent when they have equal moments. That is, the moment should be equal in magnitude and sign. In that case, the two couples are said to be equivalent. They can be replaced by one another. Okay, you see this example here. This is the first couple PP. That is, the force is P and the perpendicular distance arm is small p. So what is the moment of this couple? Capital P into small p. This is equivalent to this couple. This is completely different. No, the force is different and the arm is also different. But these two are equivalent. Why they are equivalent? Look at this. You multiply these two things, find out the moment. What is the moment? FF get cancelled and P into P only. No. So this is also of moment PP and this is also of moment PP. Therefore, both the couples are equivalent to each other. So in order to find whether two couples are equivalent or not, don't look at the force and arm, etc. Okay, just you find out the moment. If the moment of the two couples are equal, then they are said to be equivalent. Okay, they may have any force and any perpendicular distance may be there between them, right? Okay, next one is resultant of coplanar couple. So if we have n number of coplanar couples acting in a plane, then how to find out the resultant? What we have to do is each couple will be there, no? We place all the couples with the same arm, okay, and find out the resultant. So the resultant will be a single couple, okay. The resultant will be a single couple whose moment is equal to the algebraic sum of the moments of the several couples, okay. So the resultant of any number of coplanar couples acting on a body, rigid body, will be equal to a single couple, okay, whose moment is equal to algebraic sum of the moments of several couples, right. So we have seen what is the resultant of a number of couples. Next one is what is the resultant of a force and a couple. Okay, suppose if I am having a force and a couple, what will be its resultant? Definitely, they cannot keep the body in equilibrium. Whenever you have a single force and a single couple together acting on a rigid body, they cannot keep the body in equilibrium. The equilibrium cannot be achieved in this case. So there will be some resultant, no? So what is the resultant? The resultant is equal to a single force. Okay, so a couple together with a force will be equal to a single force. So what will be the magnitude and direction of the single force? That I will explain you with this example. See, I am having a force F which is acting along AC. This is a rigid body. Consider a rigid body. Okay, I have a force here and I have a couple here. This couple is having force P and arm of the couple is small p. Okay, I want to find the resultant. Whenever you have a problems of this type, what you have to do is, see, couple is characterized by its moment only. This can be replaced by another couple whose moment is P into P, isn't it? So what I am going to do is, the force P I am going to change it as F. Okay, these forces P I am going to change it as F. So if I change this as F, this arm should be replaced, no? So that the moment should be equal to P into P. So what should be the arm? PP by F. So after changing this, I am going to place this here. Okay, I am going to place this here at A. So I will get the diagram like this. This is the original force I am having here and the couple is replaced here. Okay, instead of the force P, I am changing it as F. So the arm has to be changed as what? PP by F. So already I have told you that two couples are equivalent when their moments are equal. No, that concept only I am making use here. Okay, so this is what I am having. No, now see at A, I am having two equal and opposite forces which balance each other. So the resultant of these two forces equal to 0. Finally, what are you left with? You are left with only the single force F at B. Okay, so what we are doing here, I have a force and a couple acting on a plane of a rigid body which are finally reduced to a single force. So what is the magnitude of the force? The magnitude of the original force only. Here it is F, no? The resultant is also F. Okay, what is the direction? The same direction, because the same direction only here we have taken, no? So the same direction, but only the position is shifted. Here it is acting at A, here it is acting at B. So how much distance it has moved? It has moved through a distance PP by F. Okay, so the resultant of a single force and a single couple is equal to the single force, okay, of same magnitude parallel to the original direction, but the position will be shifted. How much distance it will be shifted? PP by F. Okay, where PP is the moment of the couple and F is the original force. This much distance it has shifted. Okay, this concept is very important for doing problems. Okay, right. So this is what I have stated here. The couple PP and the force F are equivalent to a force F parallel to the original direction and at a distance what? PP by F from its original line of action. Okay, then next one. A force acting at a point A of a body is equivalent to an equal and a parallel force acting at another point B of the body together with a couple. This is just a converse of the previous part which we have proved. Previously what we have proved, one force together with a couple finally reduces to a single force, no? The same thing, the converse part here. A single force P acting at A is equivalent to a parallel force P acting at B together with a couple. And what is the moment of the couple? P into P. Okay, what is the small p? The distance through which it is shifted. Okay, right. Then next one, if three forces acting on a rigid body be represented in magnitude and direction line of action by the sides of a triangle taken in order, they are equivalent to a couple whose moment is equal to twice the area of the triangle. So here three forces acting on a rigid body, their magnitude, direction, line of action are represented by the sides of the triangle. Then what is the resultant? It's a single couple. And what is the moment of the couple? Area of the triangle. The same is extended here. So if we have any number of forces acting on the sides of a parallelogram and it represents it magnitude, direction and line of action, then it will reduce to a single couple with moment is equal to twice the area of the polygon. Okay, right. Then Next one, we have problems. The first one is ABC is an equilateral triangle of side A. Okay, this is an equilateral triangle. Each side is of length A. DEF, divide the sides BC, CA, AB in the ratio 2:1. So we have 3 points. The ABC is a triangle, no? DEF are there, which divides the sides in the ratio which ratio they are dividing? 2:1. 2:1. Here also 2:1. Okay, three forces each equal to P act at DEF perpendicular to the sides. Okay, at DEF I have three forces, all are equal magnitude. Okay, acting at DE and F and perpendicular to the respective sides. Okay, so P I have represented here. Prove that they are equivalent to a couple of moment 1/2 into P into A. So we want to find the resultant of these three forces. So whenever you have problem like this, see what you have to do is, that is we have to prove they are equivalent to a couple, no? So in that situation you have to make use of the concept that, see, I am having a force here, no? I am going to replace this force by another force along with a couple. That concept only I am going to make use. Okay, so the only thing you have to do is, where should you going to replace this force and the couple? This is equivalent to a single force and a couple taken together. So where are you going to replace it? So you should replace it so that you can easily find out the moment of the couple. In that way only you have to replace. This is an equilateral triangle they have given, no? So first time what I am going to take is, I am going to take the midpoints of all the sides. Here DEF are dividing it in the ratio 2:1 only, no? So they are not midpoints. So I am going to take A dash, B dash, C dash are the midpoints of the sides of the triangle. Okay. So what will be the line of intersection of all these things? That will be the circumcenter O. Okay. What I am going to do is, three forces P I am having here, no? I am going to replace each force into a force together with a couple at this point O. So force P at D is equivalent to a force P acting at O parallel to its original direction along with a couple. And what will be the moment of the couple? Moment equal to P into the perpendicular distance. Here only I am going to replace the force, no? So the force will be here. So what will be the moment? Equal to P into the perpendicular distance between the two lines of action. This is what I have stated in the result in the previous section. Okay, right? So what is the perpendicular distance between them? A dash D. So P into A dash D. But what is this A dash D? Look at this. A dash is the midpoint, no? So this A dash D is given by, so this part is what? This part is 2:1 and this part is what? 1:1. So this will be A dash D will be what? A by 2 minus A by 3. Okay, right. So this is equal to P into A by 6. So the single force is replaced by another single force together with a couple of moment P into A by 6 at the point O. In the same way, I am going to replace the force here. P acting at E, no, that will be replaced by a force P acting at O parallel to its original direction along with a couple whose moment will be P into A by 6, because all are equal forces and all are acting equally at a point which divides the line in the ratio 2:1, no? So the same thing. Similarly, we can write for the three forces. So all the three forces are written like this. So finally what I have? Initially I have three forces acting at DEF. Now I have removed them all. Now I have three forces acting at O, isn't it? Three equal forces P acting at O, which are perpendicular to the sides of the triangle, isn't it? They are acting along OA dash, OB dash and OC dash. Okay, acting along the perpendicular sides of the triangle. So by perpendicular triangle of forces, what can you say? Their resultant is equal to 0. Okay, here I am making use of the perpendicular triangle of forces. So the three forces which are acting at O become 0. Okay, not only I am having this, I am also having three couples, isn't it? And what are the moments? Three couples of moment, PA by 6, PA by 6, PA by 6. So what will be the resultant? The resultant will be again a couple with the moment PA by 6 plus PA by 6 plus PA by 6, which is equal to PA by 2. So two things I have, this becomes equilibrium. So only this alone I am having. So the resultant is a single couple with the moment equal to what? PA by 2. Okay, next problem. Forces 3, 4, 5, 6 and 2 root 2 act respectively along the sides AB, BC, CD and DA and AC of the square ABCD. Show that their resultant is a couple and find its moment. Okay, this is also the similar type of problem. Instead of a triangle, what we have here, we have a square. Okay, so I am taking the square and its side is of length A. Okay, so I am representing the forces along like this: 3, 4, 5 and 6. Now, as in the previous problem, what I'm going to do is I'm going to replace all the 5 forces into a single force with a couple at the point O. Here the point O I have chosen as a midpoint of the diagonal. Okay, right. Then this force of 3 unit will be equivalent to parallel force of 3 units at O along with a couple whose moment is equal to 3 into, see, we have to measure the perpendicular distance here, no? See, this is of this side is of length length A, no? That is length A. That is each side is of length A. So this distance would be what? A by 2. So 3A by 2. And similarly, this force is equivalent to another force which moment is equal to 4A by 2 equal to 2A. And similarly, this force and this force. So for all the forces I have written. Then what about this force? This force is already acting at O, no? So no need to do anything with this diagonal force, right? So finally what we have at the point O, I am having 5 forces, 3, 4, 5, 6 and 2 root 2. Okay, and 4 couples. Okay, for this one I don't have couple because it is acting along the same line itself, so its moment will be 0. So this will not form any couple. The 2 root 2, no, that will not form any couple. So 4 couples only I am having with moments 3a by 2, 2a, 5a by 2, 3a. So let me complete this one first. So their moment of the resultant is equal to what? The sum of all the moments, which is equal to 9a. Now let me come to this side. So I am having 5 forces acting at O, no? I want to find out the resultant. Already I have posted a video, mechanics video 2. In that one, I have explained how to find out the resultant of any number of forces acting at a point by using the resolved parts. That only I have make use of here. Okay, here let me find out the horizontal component of each force. See, this force is making angle 0 with horizontal. This is making angle 90 with the horizontal. This is making angle 180 with horizontal. This is making an angle 270 with horizontal, and this is making angle 45 with the horizontal. Okay, so the horizontal component will be 3 cos 0, 4 cos 90 plus 5 cos 180 plus 6 cos 270 plus 2 root 2 cos 45. So simplify this result. 3 minus 5 plus 2 root 2 into 1 by 2, which is equal to 0. So the horizontal component is 0. Similarly, the vertical component is obtained by replacing all cos by sine. Okay, that is also equal to 0. So what is the resultant of all the forces? Square root of x square plus y square, which is equal to 0. So the 5 forces acting on the rigid body is reduced to 5 forces along with 4 couples. But this resultant is equal to what? 0. And this resultant is equal to a couple with a moment 9a. So the final resultant is this one only. Okay, then one more problem we'll see. PQ are like parallel forces. A couple of moment G is combined with them. Show that the resultant of two parallel forces is displaced through a distance G by P plus Q. Very simple problem. See, let us take two forces PQ, like parallel forces acting at A and B. Then their resultant will be acting at C. The resultant is P plus Q, which is acting at C, where P into AC equal to Q into CB. For this, you can refer the video which is I have posted on parallel forces. Okay, then I have a moment whose I have a couple whose moment is equal to G. Okay, so whenever you have a force and a couple, what I told you, replace that couple with this force and with this arm, isn't it? So I am going to replace it with the force P and arm AB. So this force into arm, that is the moment, is equal to what? It should be equal to G, no? Okay, so replace that couple in this position. So I am having this diagram. This is my already I am having that PQ, and this is the couple which I am replacing. So here I have one P and here I have one P. This P and P will be equal and opposite. They will balance each other. So 0. Finally, I am having P plus Q, resultant P plus Q here. Originally, I am having the resultant here. Now I am having the resultant here. So the resultant is displaced from C to B, no? So this is the displacement of the resultant. So the displacement of the resultant is CB. So I want to find what is the value of CB. Now look at this part alone. So CB equal to what? AB minus AC, no? So for AB, I am going to make use of this result, G by P. And for AC, I am going to make use of this result, Q. For what is that? AC, Q into CB. Right, sorry, Q by P into CB. So now you throughout you multiply by P. So P into CB equal to G minus Q into CB. So P plus Q into CB equal to G, or CB equal to G by P plus Q. Therefore, the resultant P plus Q is displaced through a distance, what? G by P plus Q. Okay. Okay, I hope you understand all the problems discussed here. That's all. Thank you.